Hello and welcome to the session. Learning Outcome LO3, understand basic mathematical formulas for computing mathematics. How do mathematical formulas enhance computing? They form the backbone of programming, data analysis, and system design. Discover how these essential tools drive precision and efficiency. Arithmetic is the foundation of computing, enabling operations like addition and multiplication. These are integral to programming languages for calculations and indexing. Understanding arithmetic is vital for developing logical solutions. Key formulas include the mean, used to calculate averages in applications. For example, determining average user ratings on websites. Percentage formulas are crucial in computing for proportionate calculations. They are used in financial computations and progress tracking. A key formula is percentage calculation, vital in user interfaces. For example, progress bars show task completion percentages. These calculations are essential in simulations and graphics, requiring spatial computations. Area and volume formulas are pivotal in computing graphics and simulations. They help in determining space occupied by objects in three-dimensional environments. Key formulas include the area of a rectangle and volume of a cube. These are applied in user interface design and simulation modeling. Understanding these helps in creating efficient layouts. Geometry and trigonometry are essential for animations and robotics. They calculate angles, distances, and movements in two-dimensional and three-dimensional spaces. Key formulas include the Pythagorean theorem and trigonometric ratios. These are used for calculating distances between objects in games. Understanding these formulas aids in precise movements and rotations. Algebra in computing helps formulate and solve equations. It models relationships and performs operations using variables. A key formula is the linear equation, used in machine learning. For example, it's applied in linear regression for predicting outcomes. Understanding algebra is crucial for data modeling and prediction algorithms. Logic operations, though not numerical, are mathematical and crucial in computing. They underpin flow control and decision-making in digital systems. Key expressions include and, or, and not. These are used in conditional statements and decision-making in AI. Understanding logic is vital for programming control structures. Statistics in computing helps understand trends and make predictions. Key formulas include mean and standard deviation. These are used for data analysis and performance monitoring. For example, assessing server response times or tuning machine learning models. Understanding statistics aids in accurate data-driven decision-making. Addition combines numerical values and is fundamental in computing. It's used in formulas for calculating totals and updating counters. Common examples include adding items to a shopping cart. In algorithms, addition increments loop variables. Understanding addition is crucial for data processing and algorithm development. Subtraction calculates differences and is essential in computing. It's applied in reducing quantities and comparing values. Common use cases include calculating time differences and determining reductions. In algorithms, subtraction is used for distance calculations. Understanding subtraction aids in effective problem solving. Multiplication scales values and is pivotal in computing. It's used in formulas for calculating area and scaling graphics. Common examples include calculating total costs based on quantity. In algorithms, multiplication is used for performance scaling. Understanding multiplication is essential for resource allocation and scaling operations. Division splits values and determines ratios in computing. It's used for calculating averages and converting units. Common examples include calculating average scores and resource distribution. In algorithms, Division normalizes data and adjusts metrics. Understanding division is crucial for balancing resources and unit conversions. Functions and equations are essential for calculations in computing. Functions are reusable code blocks, while equations represent relationships. They enable accurate data manipulation and algorithm building. Understanding their application allows automation and statistical analysis. These tools solve real-world problems efficiently. Mathematical functions are predefined operations in programming. They take input values and return computed results. Common functions include absolute value, rounding, and square root. These are used for error measurement and geometric calculations. Understanding mathematical functions is vital for efficient programming. Equations define relationships between variables in computing. They use arithmetic operators and constants for algorithm development. Common equations include area and volume calculations. These are applied in graphics and spatial analysis. Understanding equations is crucial for data modeling and system analysis. Algebra involves symbols and rules for manipulating them. In computing, it's used to formulate equations representing real-world problems. Algebra helps abstract problems into mathematical expressions. It's useful in software development and data analysis. Understanding algebra enhances problem-solving and system modeling. Algebra is used to rearrange formulas and solve unknowns. It models relationships and simplifies programming logic. Common applications include calculating unknown parameters. Algebra is essential for dynamic calculations in real-time systems. Understanding its use enhances decision-making and performance optimization. Consider a formula calculating total purchase cost. If total cost and unit price are known, algebra solves for quantity. This is used in shopping carts to determine item counts. Understanding this application aids in effective inventory management. Algebraic solutions simplify complex computing problems. In performance monitoring, formulas calculate speed from distance and time. Algebra rearranges to solve for unknown speed. This is used in logistics for route planning and optimization. Understanding this application enhances system efficiency. Algebraic manipulation is key to accurate computing solutions. In tax calculations, algebra finds net prices from total prices. By rearranging formulas, unknown values are determined. This is used in accounting software for pre-tax calculations. Understanding this application improves financial accuracy. Algebra simplifies complex tax computations in software. In linear models, algebra solves for unknown variables. Given an equation, known outputs determine input values. This is used in machine learning for regression analysis. Understanding this application enhances predictive modeling. Algebraic solutions drive accurate, data-driven decisions. In conclusion, understanding basic mathematical formulas for computing mathematics is essential for building strong analytical and programming skills. Formulas related to algebra, logic, functions, and numerical operations serve as the foundation for algorithms, data processing, and computational problem solving. By mastering these fundamental concepts, learners can create more accurate and efficient code, interpret data effectively, and approach technical challenges with confidence. A solid grasp of mathematical formulas not only enhances competency in computing, but also supports progression into more advanced areas of computer science and software development. Thank you for watching this video. If you have any questions, please feel free to contact us via email or WhatsApp at 0748 436 1688.